from group 3 from BMM 3552 mechanical vibration. We'd like to present to you about our experiment, which is force vibration experiment. From the experiment, we are able to determine two objectives, which is the first one, to determine the decay rate of the system, and two, to determine the natural frequency of the system. Firstly, I would like to tell you the tools that we use to conduct the experiment. Firstly is the motor itself. Secondly is the speed controller, which controls the speed of the motor. Thirdly is the beam. Fourth is the EAQ, which is the data acquisition system. And fifth is National and Measurement Explorer. And lastly is the DAISY Lab itself. For first experiment, we want to know the decay rate in the system. For this experiment, we use the three different mass. First, 100 gram, 3 and 500 gram. Then we construct the data collection in the DAISY Lab. Then we pull down and hold the beam, and then release the beam. From the graph in the DAISY Lab, we find the Y, T and F. This is for Y, Y1, T1 and F1. Then we find the Y1, T1 and Y2, T2 and F2.
We want to determine the natural frequency for different speed, which are 4 RPS, 6 RPS and 8 RPS. Firstly, we set up the desired speed by using speed controller. Make sure the weight is in fixed position and unable to move. Next, we construct the block diagram inside the DAISY Lab software. We adjust the value from 4 RPS until 8 RPS.
Next, from the DAISY Lab worksheet, we will obtain a sinusoidal graph. From that, we will get the value of amplitude, time duration of each cycle and time per cycle. Based on that, we will plot the graph by using Excel and get the result.
Now I want to present for our table and the result. This is the table for the experiment where we use 100 gram of mass, and this is the effect to the decay rate. This is Y. We record the value of Y, T, F and ln Y, and then we plot the graph. Here, this is the graph for 100 gram, and then we proceed with a mass of 300 gram and we tabulate the data as usual. And then this is the graph for 300 gram mass. Then we proceed with 500 gram mass and we tabulate data as before. We take the value of Y, T, F and ln Y, and when we can see the gradient of the graph as we draw. And then after that, this is the table for the data of natural frequency experiment. In this experiment, we use 3 speed, 4 RPS, 6 RPS and 8 RPS. This is the table for speed 4 RPS. We do by using 4 cycle, and for every cycle we take the start and the maximum amplitude, minimum amplitude, and the time per cycle. This is the data we take. This is the graph we plot by using the data. For the speed 6 RPS, this is the table where the start is, for example, 0.122 and we take 4 cycles. This is the graph for 6 RPS. We continue with 8 RPS. This is the graph like before, and this is the graph we plot. This is the final graph for the natural frequency. You can see the amplitude very clear. And this is the decay rate graph. Curve. You can see the curve of the graph. And this is the equation we get. That's all from me. Thank you.
As a conclusion, we are able to meet the objective of our experiment, which is one, to determine the decay rate of the system, which we are able to determine that the decay rate depends on the mass. And secondly, we want to determine the natural frequency of the system, in which it depends on the speed of the motor. That's all. Thank you.